The next paper that we have is LoRaWAN-based mobile air quality monitoring, and I would like to invite the authors, Assistant Professor Dr. Sundus Ali, Professor Dr. Muhd Imran Aslam from Telecom Department in NAD University of Engineering and Technology.
Assalamu alaikum everyone. So thank you for inviting me to present our work on the development of LoRaWAN-based mobile IoT systems for real-time climate monitoring. Basically, my co-author Dr. Sundus was about to present this work, but unfortunately, due to some circumstances, I am presenting this work now. So this is, in this work, I will be presenting our work related to developing an environmental monitoring system. This work is basically supported by Sindh Higher Education Commission. There was a research grant that was provided in developing this work. So can we move on? So why we are doing this? The important question is we need to have such solution because the industrial revolution that happened in past few decades has severely impacted our environment. We are facing degradation in the environmental parameter at a very, very high rate, which is causing significant health problem as well as other issues to our ecosystem in form of the degradation is in degradation in the agricultural land, degradation, contamination in the water, and so on. So we are having this problem for quite long, and there is need to have solutions which are scalable and which can effectively monitor all these parameters. So if we talk about the reports, international reports, WHO says that almost 99% world population is facing the problem of pollutants in some way or other. And there are some areas where this exposure is very high, even such high that it is leading to premature deaths. So it is important to have consideration of this aspect. The more focus is related to the carbon monoxide and carbon dioxide gases because they are harmful for human inhale when they are inhaled by human, and ammonia gas, which is actually significant source for agriculture contamination. So ammonia gas is also a very is a point of concern. This results in health problems, degradation in the agricultural land, crop degradation. It results in water contamination and so on. Can we please move on? So conventionally, what happens in this weather monitoring or environmental monitoring is used to be done conventionally by the governmental bodies. They used to have conventional setups. एक weather station लगा दिया कहीं पे और वहाँ पे they are doing that. These stations they cost a lot and they are sparse. पूरी कराची में देखें तो you would see a couple of stations that would cover. But the problem these days is that the pollutant concentrations are changing over a very small distance. Even in this work, we actually noticed that a significant change in the pollutant concentration even at a very small distance of 100 meters. So we cannot deploy those conventional stations to at every 100-meter interval. So actually we need to have some solutions which are scalable, which are low cost, which are easy to handle, and which can handle a significant amount of data. Next slide पे जा सकते हैं please.
Next slide, please.
Okay. इससे भी आगे. Thank you. So what we are doing, we need to have this scalable solution so that we can cover as much as possible data area with a reliable data in order to understand what changes are happening to our environment and where are the pollution hotspots. Because even in the city, if you see that all areas are not the same, there are certain positions which can be treated as pollution hotspots, where you would feel significant amount of pollution as compared to the other areas in the city. So what we did in this work, we actually used a communication protocol. I'm from Telecommunication department, NED University. So we used a special communication protocol, LoRaWAN. LoRaWAN is a communication standard developed specifically for Internet of Things, because Internet of Things has some limitations. Firstly, it's small size. It operates on battery, so it has a limited amount of power. You cannot use unlimited amount of power. Thirdly, we need to have communication over a longer ranges. So you need to establish communication over distance of sometimes kilometers. So in order to cover these gaps, this LoRaWAN protocol was developed, and in 2023 PTA also adopted this protocol in Pakistan and started to issue licenses to the local companies as well. So we have now infrastructure available for LoRaWAN in Pakistan. So we utilized this thing to develop our system. Kindly move on. Okay. So before going into the hardware detail, let me show you how the system that we have developed works. So basically you can divide the system into three major components. First is the front end of the system. What we did, we collected different types of environmental monitoring sensors. These sensors are typically very low cost sensors. They can monitor carbon dioxide, carbon monoxide, ammonia gas. In addition to that, we also installed particulate matter sensors. Particulate matter is, you can treat them as a dust particle, which when they are inhaled, they get stick to lung and they cause, you can say, infections there. So particulate matter concentration is also to be gathered. We are gathering particulate matter concentration of diameter 10 nanometer, 2.5 and PM1. So we use this thing. Plus additionally we are attempting to have more sensors related, for example ozone gas sensor, which is sometimes affecting the industrial as an industrial waste. So we are also integrating those parameters. So for the timing I will stick to carbon dioxide and ammonia and the PM matters. So what we did, we actually had a front end where these sensors are integrated with the microcontroller, and that microcontroller is equipped with the LoRaWAN transceiver, which can transmit the data to the central server. The second part is the network server, which actually collects the data coming from that sensor. For this purpose, we use WizGate standard LoRaWAN gateway, which is used to collect the data coming from the sensor node. And then the network server actually connects to the application server where this data is stored. This data can be visualized to see the real-time parameters. This data is saved and processed. What we can do, we can take the temporal data or spatial data at different time instances or different spaces and correlate them to see how the pollutants are changing over the time or over the space. So we can make analysis and prediction in order to judge how the parameters will be after few months or few years from now. So we can make the predictions onto that as well. So can we move on, please? Yes. So when we started this work, what was our research objectives? So our objectives was the development of LoRaWAN-based IoT system, which is capable of monitoring the environmental parameters. Then we integrated different sensors, including PM level, CO2, temperature, humidity. They are typical, carbon monoxide and ammonia. These sensors, they collect the data and transmit over the LoRaWAN protocol over a long range. This LoRaWAN that we have developed, because Karachi has a relatively denser environment, this can communicate around 2 kilometers at a 2 kilometer distance. But for the open environment, the range can be extended up to, you can say, 15 kilometers. So it has a capacity of communicating to the very long range without having investing on an infrastructure. So, okay, then also because once the data is collected, you have to visualize and process it. So we can visualize the real-time sensor data, and we have developed a cloud-based dashboard, and then we are applying some machine learning techniques there to make the predictions onto the collected data. Although we have currently we have a smaller amount of data, we are in the phase of collecting more data, and so that because in machine learning the more data results in more accuracy of your prediction. So we are still in the process of collecting more data there. Can we move on, please? Yes. Okay. So this would be the flow of your of our system. As I said, sensor. When we developed, we started with the sensor. So we in the laboratory environment we gathered those sensors, we calibrated and tested in the lab environment. Then we integrated those sensors with the microcontroller. Then we developed the node configuration for those sensors. We developed the sensor nodes so that it is configured properly to set the LoRaWAN frame and transmit over a long range. Then we integrated with the microcontroller and established the communication with the gateway, which actually collected the data at the gateway. One thing that I missed earlier was this gateway is capable of handling large number of nodes. So we don't need separate gateways for different sensor nodes. So what we can do, we can have one gateway which covers an area of, say for example, 2 kilometer radius, and we can deploy sensor nodes at shorter intervals, and all of them they connect to the gateway. It's kind of, in technical terms, you can say that we can develop a kind of star topology or star of star topology in order to extend the communication distance over a large distance. So we can have a coverage of entire region with the deployment of those sensors. Then once the data is collected, we actually integrated it with the cloud server. That cloud server was developed through Things network, which actually collects the data coming from different sensors that we deployed, and it stored the data and started applying that machine learning algorithm. And then we have also developed a dashboard to see the real-time impact coming from those sensors. Can we move on, please? Okay. So main features that we had. So this is the illustration. So we have different nodes illustrated as sensor node 1 and sensor node 2. Both of them, they are connected to a LoRaWAN gateway, which is at the back end connected to a network server, and then the network server is connected to application server for data visualization. आगे चलें please. Okay, so this is the prototype that we have developed. On this black thing is a gateway, which is a standard WSGAT gateway, which can connect number of nodes. At the front end, it is connected to the LoRaWAN sensor node. At the back end, it is connected to the application server to send the data at the server. This breadboard thing is actually the controller. It's a microcontroller which has the capability of LoRaWAN transmitter. So it integrates the LoRaWAN into that, and so it gathers the data from the sensors, arrange them into the frame form, and then transmit. This small blue thing, that was in carbon monoxide sensor, and similar sensors are there. Carbon dioxide sensors, they were all integrated to the same circuit. In order to have the mobility, we actually powered it through batteries. So you can power it independent batteries. आगे चलिए please. So this was the first node, and another node we developed which had the ammonia sensors and carbon dioxide sensors integrated with them. The blue one is the particulate matter sensor, which gathers the information on the particulate matter. Again, that is powered by the batteries to maintain the mobility of the node. आगे चलिएगा please. So that was actually prototype that was developed in the lab, and then we assembled it into you can say in the PCB form, in a product form, so that we get a compact system for the server. So you can see that these are the top two. They are actually two different nodes which have been developed. They integrate the sensor as well as the microcontroller, plus we have some display onto that node as well. Even if it's not transmitting the data, even if you can see the data locally which is gathered by different nodes. Second is also another PCB. Third is the casing developed for that PCB. So this entire thing is actually encapsulated in that casing to maintain the integrity of the system, and the battery bank is also integrated into that, so that you can move around with that thing easily. So eventually, after testing everything, we ended up in this compact product, which is capable of gathering the environmental parameter at any place. Plus, we actually, in order to ensure the spatial location, we can also integrate the GPS. On this one, in another node, we have also integrated the GPS sensor as well, so that we can get the exact location where the data is being gathered. आगे चलिए. Okay, खैर ये तो वो flow है. I have already discussed that flow previously, because first we gather the environmental data, then sensors transmit that data to the server, and eventually after some data processing, you can visualize that data. Can kindly move on. Okay, this is the illustration of the dashboard that we have developed. Actually this gives you a real-time picture of the environment where the node is placed. So Prof is just header to show that this work is done under the SIN Research Support Program. The bottom one is actually showing you the picture of the environment, what type of situation is there. So we use different color codes to indicate which sensor, which parameter is at what level. For example, green is actually showing that this is not in the dangerous state, and red shows the it has passed the WHO threshold of the limit of that particular center. For example, in this illustration, PM 10 value is 101 microgram per meter cube, which is dangerous if it is inhaled for a longer period of time. Inhale instantly increase होना problem नहीं होता. Eventually the problem occurs when it is inhaled for a longer period of time. Okay. So this was the overall dashboard. The number at the end 190. After collecting that parameter, 190 is giving the air quality index, AQI, which is typically reported to present an environment. So AQI value at that instant when we took this snapshot was 190, which is considered unhealthy for that environment. This was this node at that time. It was near NAD University. I'm not sure if you have seen that. Muskan, there is a Muskan Chaurangi, so वहाँ पे थोड़ी सी situation normally vulnerable होती है. Can we move on, please? Okay. So what we did, because our intent to have a system which is mobile, it should not be fixed at one location. It should you would be able to carry it any point where you want to make your measurements. So what we did, we made a drive testing to that. So this blue line in the bottom curve, this blue curve is actually showing you the path that we actually traced out while taking the readings at different instances. A, B, C, D, these are the locations where we collected the data. So we started from point A, we moved to point B, C, D, and then we tried to analyze how this environmental parameter they are changing when we change spatially. from one point to another point, how this changes is happening. So this drive testing showed that our our node which was developed, it remained connected to the gateway. It satisfactorily collected all the data, and also it actually retains the integrity throughout the mobility. आगे चलिए. Okay. So at the end, what I want to say is that so far we have, because it's an ongoing work, so far we have developed a compact node which is capable of monitoring or collecting the critical environmental parameter at some instance, and it is capable of recording all those parameters at a dashboard, and then we can use it for visualization as well as for data processing. So for this presentation, actually I showed you only the visualization purpose, the dashboard that is showing the real-time picture. But next thing that we are discussing is, we are working on, is to gather data for some time, say for a period of 6 months or 1 year, so that we get enough amount of data, and then we can use the machine learning onto that data to analyze the trend, how these changes are affecting, or the environment is being affected over the time, over the different durations. And also second thing that we are working is on the spatial correlation, especially if you change the location from one place to other, so how this will be impacting the environment. मैं just as an example दे दूँ, even in this dive test, we noticed that there was a temperature difference of 3 degrees at a distance of around maybe 100 meters, बल्कि शायद उससे भी कम था, because at one side we were exposed and close to the hot spot in Maskan Chaurangi, and at the other side we were inside the university campus where there was a significant amount of tree plantation. So you can see that that even for that small region, the temperature difference of 3 degrees is really significant, which critically shows that the difference in environment is actually affecting our you can say the critical parameters of environment over a very, very small distance. Second thing that we are working on, because this node development is actually related to general use, because carbon dioxide, carbon monoxide, ammonia, they are typical problem in industry. In human normal use, residential life and agriculture life, but there can be some problems related to industries specifically. For example, ozone gas. In some industries, ozone can be a problem. So we can have a similar node to detect the ozone gas in the particular industry, or similarly we can have other environmental parameter, and also the water contamination things being monitored through these IoT systems. So
we'll have to interrupt you, but
it's done. Okay.
All right. Thank you so much.
Thank you.
Thank you so much, Dr. Imran,
thank you everyone
for an insightful project related to environmental monitoring, which is also need of an hour. So as we come towards conclusion of the session, I would like to open the floor now for any question answer session. I do request anybody who wants to ask the question to please introduce themselves and target the author they want to ask question. So the floor is open, please. Please hand over the mic to the person, to the audience. And raise your hands if you want to ask the question, please.
Assalamu alaikum. I am Dr. Naseem, President, Pakistan Academy of Engineering. My question is to Imran Aslam, Dr. Imran Aslam.
Can you please come forward?
और चलते चलते मैं सवाल करता चला जाऊँ. डॉक्टर साहब, जस्ट लेट मी नो कि आपकी प्रेजेंटेशन से ऐसे लगा जैसे पाकिस्तान खुद sensors बना रहा है. Do we have the sensor technology also in each one of them?
अच्छा, जो सिस्टम हमने यूज़ किया है उसमें हमने खुद सेंसर बनाए नहीं है. वी यूज्ड द बिल्ट इन सेंसर्स, लेकिन बट देयर आर सम अदर ग्रुप्स हु आर डेवलपिंग सेंसर्स एज वेल. हमने नहीं किया काम, ये अलग बात है, बट if needed we can figure out that. I know they are primarily, the sensor development is more related to chemical engineering rather than this electrical side. So but I know there are some people who are working in that area.
That means we do have sensors in Pakistan. You confirmed about that, and why did you use those sensors?
No, because these sensors that we use, they are kind of becoming standardized in this area, and secondly they are very cheap. So the node that I developed, this entire node could have cost maybe is I think $5 maybe. So it is a very cheap sensor, that why we use this.
Okay, डॉक्टर साहब ये बताइएगा कि आपके नेक्स्ट फ्यूचर में भी कुछ प्रोग्राम है.
जी हाँ.
तो नॉइज़ पोल्यूशन का आपने सोचा कि उसकी मेजरमेंट होनी चाहिए?
हाँ, अभी तक हमने नॉइज़ पोल्यूशन पे काम नहीं किया, ऑनेस्टली स्पीकिंग, कि हमें नॉइज़ पोल्यूशन को नहीं किया. बेसिकली अभी इस वक्त जो हमारा काम चल रहा है वो एयर क्वालिटी एक, और सेकंड वाटर कंटेमिनेशन में कुछ चीज़ें हमने अभी शुरू की हैं, तो वो अंडर प्रोसेस हैं. बट एट लेटर स्टेज मे बी वी मे इंक्लूड दैट एरिया एज वेल, बट फॉर द टाइमिंग वी आर नॉट डूइंग दैट.
उसके बारे में कोई डेटा भी पाकिस्तान में नहीं है, लेकिन जनरली हम महसूस करते हैं कि हम लोग कुछ ज़रा ऊंचा सुनते हैं. लाउड स्पीकर का भी अब इस हॉल में आप देख रहे होंगे कि क्या हशर है, या बैकग्राउंड नॉइज़ होता है जो डिस्टर्ब करता है अक्सर. तो इसके बारे में भी आप तहकीक कर लीजिएगा.
बिल्कुल, ये किया जा सकता है. और नॉइज़ पोल्यूशन इफेक्टिवली एक्चुअली इस वक्त जो हमारे पास सिचुएशन है, जो रोड साइड सिचुएशन है वो बहुत ख़राब है. आपके पास हर वक्त एक हॉर्न बजाता रहेगा, एक फटफटी जारी होगी जिसमें से आवाज़ें आ रही होंगी. तो वी आर बिकमिंग यूज्ड टू ऑफ दैट थिंग. दिस इज स्टिल अ प्रॉब्लम. एट NIT यूनिवर्सिटी एक्चुअली वी इनिशिएटेड अ थिंग विच इज़ कॉल्ड हेल्दी फ्राइडे. अभी तो गर्मी ज़्यादा हो गई है तो अभी इसको सस्पेंड कर दिया, लेकिन जब मौसम बेहतर होता है तो व्हाट वी डू, एवरीवन पार्क्स देयर कार एट द गेट एंड वॉक्स इनसाइड द कैंपस. तो उसको हम हेल्दी फ्राइडे कहते हैं एक्चुअली. वन ऑफ द इम्पैक्ट दैट वी ऑब्जर्व्ड वाज द रिडक्शन इन नॉइस. कि जो कैंपस का इन्वायरमेंट है उसमें वो जो नॉइज़ का पैरामीटर है, इन्वायरमेंटल इम्पैक्ट तो है ही है, वो हमने एक्चुअली थोड़ा मेजर भी किया उसके असेसमेंट, ऑल्दो आई डिड नॉट प्रेजेंटेड हियर, बट वन ऑफ द फैक्टर वाज देयर. सो सिर्फ इतने से फ़र्क से कि गाड़ियाँ आपने बाहर पार्क की हैं और अंदर नहीं आ रही, तो उसका भी इम्पैक्ट नॉइज़ पे आ रहा था. तो यस, इट इज़ अ इम्पॉर्टेंट थिंग, बट अनफॉर्चुनेटली फॉर द टाइमिंग वी आर नॉट डूइंग दैट, बट विल कंसिडर इट इन फ्यूचर इंशाल्लाह.
डॉक्टर साहब, मेरा नाम इंजीनियर परवेज सादिक है और मैं इंडस्ट्रियल कंसल्टेंट हूँ. इसके अलावा सिंध एनवायरनमेंटल प्रोटेक्शन एजेंसी के सो कॉल्ड एक्सपर्ट भी हूँ, तो वो बुलाते हैं. तो आपकी चीज़ से बहुत हम इम्प्रेस हुए हैं और खाली आगाह करना चाह रहा हूँ आपको, और आपको चाहें तो वकार पुल पोटो हु इज़ द डायरेक्टर जनरल सीपा, उनसे भी मिलवा दूँ, क्योंकि हमारे यहाँ लोग अनफॉर्चुनेटली इंपोर्ट करने के चक्करों में होते हैं. अगर वाकई आपकी चीज़ अच्छी है तो काफ़ी सस्ते में काम हो जाएगा, क्योंकि ये जो सेंसर्स हैं जो 8-10 किस्म के पैरामीटर्स को चेक करते हैं, वो राउंड अबाउट 7,000 यूरो का एक पूरा यूनिट आता है IoT के ऊपर बेस्ड. तो आपसे लिंक रखेंगे. और अगर आप अच्छा, प्रॉब्लम गवर्नमेंट की जो कल भी शायद चीमा साहब ने भी कहा था, होता क्या है कि वो रूल्स ऑफ परचेज और गवर्नमेंट के और नैब का चक्कर चलने लगता है, तो वो फिर आप जैसे लोगों को प्रमोशन नहीं देते और वो रिस्क लेने को तैयार नहीं होते. तो इन शॉर्ट वेरी मच इम्प्रेस्ड. अगर आप चीज़ को करेंगे तो वी कैन पुट यू इन टच.
थैंक यू सर, थैंक यू फॉर योर ऑफर.
हम
ज़रूर इसको कंसिडर करेंगे. फॉर्चुनेटली यस्टरडे आई मेट विद डॉक्टर वकार हुसैन पोटो साहब. एक फॉर्चुनेटली
वो अच्छे आदमी,
तो कल ही उनसे कुछ हुआ. वी हैड सम डिस्कशन ऑन टू दिस थिंग्स, बट ऑफ कोर्स इट विल टेक सम टाइम टू मटेरियलाइज. थैंक यू सर.
सर आई हैव क्वेश्चन.
Yes,
सर आपने जो कार्बन फुटप्रिंट के लिए जो सेंसर यूज़ किया है MQ, उसके टाइप कौन से 2, 5
actually-
और इसकी सेंसिटिविटी क्या थी, क्या पीपीएम थे?
बेसिकली वो है MQ7 जो इसमें यूज़ किया हुआ है, जो ये वाला नोट शो किया है वो MQ7 है, बट सॉरी आई फॉरगॉट दैट नंबर. वी इन अनदर थिंग एक्चुअली वी आर डूइंग ये MQ7 का एक थोड़ा सा प्रॉब्लम ये होता है कि इसको आपको कैलिब्रेट करना पड़ता है. आपको एक प्रॉपर थोड़ा सा टेस्टिंग इन्वायरमेंट में लाके उसको थोड़ा सा कैलिब्रेट करना होता है. तो वी कैलिब्रेटेड दैट थिंग इन अ स्पेसिफिक सिनेरियो and then we used it, but there are few sensors available which are pre-calibrated जो बाकायदा आते हैं, थोड़े से कॉस्टली होते हैं इसके मुकाबले में, काफ़ी ज़्यादा कॉस्टली होता है एक्चुअली. ये 1000 रुपये का है तो वो तकरीबन 25,000 का है, इतना फ़र्क है एक्चुअली.
I move forward in next question.
we have that thing as well. तो वो एक्चुअली हम क्या करते हैं, हम we have that one, we use it as a standard and we calibrate it and we compare the readings with these two. तो बेसिकली हमने rather than having a separate calibration setup, we use a pre-calibrated center to calibrate the uncalibrated center.
नेक्स्ट क्वेश्चन इज सर, आपने कहा है डिफरेंट नोड्स बनाए आपने A,
Sorry,
B,
I
C, D,
did not-
डिफरेंट लोकेशन पे आपने कार्बन मोनोऑक्साइड डेटा कलेक्ट किया है. तो आपने हर जगह अलग अलग गए हैं, फिर डेटा लिए हैं, या सेम टाइम में हमने हर पॉइंट पे डेटा लिया?
नहीं, ये दिस वाज अ मोबाइल नोड एक्चुअली. सो हमने क्या किया, मतलब मोटरसाइकिल पे रखा नोड को, ठीक है, यहाँ पे, फिर उसको दूसरी जगह पे लेके गए, फिर दूसरी जगह
तो
पे लेके
आप
गए.
उसको क्यों नहीं यूज़ कर
So
रहे हैं,
it's not
ब्लॉकचेन?
at the same time.
तो ब्लॉकचेन को क्यों नहीं यूज़ कर रहे हैं? सेम टाइम आपका डेटा एक साथ आएगा एक सर्वर रूम पे.
नहीं देखिए, वो ठीक है एक साथ तो आएगा, बट यू नीड मल्टीपल सेंसर्स ना. अगर आपको मल्टीपल लोकेशंस पे लेना है तो आप उतने ही सेंसर भी चाहिए होंगे. फॉर द टाइम बिंग वी हैव डेवलप्ड ओनली 2 सेंसर नोड्स, so we can place it at 2 positions simultaneously.
As you said, your sensor were cheaper, 200, 300. At this
cheaper
cost.
तो सेंसर तो cheaper, but the development of that sensor takes time.
अच्छा, what was a microcontroller? It was Arduino Uno या Raspberry Pi?
No, it was ESP.
ESP32.
Yes, not ESP32. ESP has a variant which has LoRaWAN capability. So that was ESP capability node controller, but I forgot that number actually.
Okay, thank you.
Thank you.
Any other questions from other authors, please?